Hi, I'm Mr. Huber, and in this video I would like to talk about problem 8. A car is purchased for $40,000. The value of the car will be less each year because of depreciation. The car depreciates, loses value at a rate of 25% per year. Write the depreciation function in the following two forms. Well, as a normal exponential function, and here as an exponential function with a base e. Give one advantage of the first form, and after how many years is the car for the first time worth less than $5,000? Okay, well, the first part is very easy because value after t years is 40,000. That's the initial value. So after 1 year, you lose 25%, so you're left with 75%, so 0.75. Very important, don't write 0.25 here, because you lose 25%, so the remaining value is 0.75 of this amount, or 75% of the initial value, so to the t. Then for the second form, you start off the same way because the initial value is the same thing, e to the kt. Now you see you have to compare these two terms. So 0.75 is equal to e to the kt. 0.75 to the t is equal to this, which means 0.75 is equal to e to the k. Why is that? Because you could write e to the k to the t. So you have, so you can compare the base, okay? So the base has to be the same. So these are the bases. Now you have to use the ln in order to isolate the k. So ln 0.75 is equal to ln e to the k. Well, this is just k because e to the what is e to the k. It's obviously k. So it's ln 0.75, and if you wanted, you could write k is equal to approximately minus 0.2877. So now your function becomes this. V of t is 4,000 e to the ln 0.75 times t, or 40,000 e to the minus 0.2877 t. Well, we've seen functions like these in problem 7, 6, and 5. Okay. Well, this is only approximately equal to this because we have used a rounded value. Okay, one big advantage of this first notation is that you can see that you lose 25% per year. That's one big advantage. We will only be able to understand the advantage that such a notation could give us in year 6. Okay, for the moment it's not clear why this is a good notation. But the one thing to keep in mind, you can write every exponential function as an e function. Okay. Now let's do c. I'm going to use, you could use either of them. I'm going to use this one, 40,000 times 0.75 to the t is less than 5,000. So 0.75 t is less than 1/8 if you divide by 40,000. Now you use the ln on both sides. You apply the ln on both sides. So that's ln 0.75 to the t less than ln 1/8. You can take out the t, ln 0.75 less than ln 1/8. Now you divide by this, but please be careful. This is a number between 0 and 1, so this will be a negative number, so you have to change the sign. ln 1/8 divided by ln 0.75. This is approximately equal to 7.23 years. So t is greater than or equal to 8 years. So after 8 years, the worth of your car will be below $5,000 for the first time. Let me just re-explain this step here. Well, you have your ln function, which is the inverse function of the e to the x function. This is 1. This is the x-axis, the y-axis. Whenever you plug in something greater than 1, you'll get a positive y value. If you plug in something between 0 and 1, you're going to get something negative. For example, 0.75, that's about there. So you're going to get a negative y value. That means this value will be negative. Look at this. Well, we calculated it before. It's just minus 0.2877. So you're dividing by this negative number. So please be careful. I hope it wasn't too difficult. See you in the next one.